Algebra 2. Currently we're working on monomial polynomial unit. We have already looked at the definitions, vocabulary for monomial and polynomial, as well as coefficient and constant. We looked at the product rule, the power rule, quotient rule, negative power rule, and the zero power rule. And now we're going to look at polynomial rules. And remember from the past that polynomial, poly is the prefix, and it means many terms. So in these problems, instead of having one term in parentheses, you're going to have multiple. You could have 2 terms, 3 terms, or so forth. So the first type of problem we're going to be looking at is how to add and subtract polynomials. And this is very straightforward. You just need to make sure that you're following exactly the steps you see. First, you need to group like terms. Like terms means terms that have the same variable, but also the same power. So like x to the second and x to the second are like terms. However, x to the third and x to the second are not like terms. So you're going to group those terms side by side. So you will have to rearrange some of the problems. Again, you want to group your like terms, write them side by side. Secondly, I want you to look for a subtraction sign in the middle. Some problems will be addition and some will be subtraction, but the ones that are subtraction, the rule says that you have to change all signs of the terms behind the minus sign. So I'll show you an example of that in a second, but if it's a subtraction problem, there is an extra step. You do have to change all the signs of everything behind the minus sign. Next, you're going to add and subtract, depending on the sign, add or subtract the coefficients on like terms. And then last, do nothing to powers. So like we've learned all kinds of different rules for monomials. Some rules we had to add powers, some we multiplied, sometimes we subtracted powers. But if we are just adding and subtracting polynomials and grouping like terms, your powers are not going to change. You're just going to drop those down on each term. Okay, so let's take those rules, those steps, and let's apply it. Look at example 1. The directions are just very simple. It says simplify. And in number 1, you should see in the first parentheses there are 3 terms here. And you can tell that because the plus and the minus signs help separate them. That's a really good way to tell. There are 3 terms currently on the board in the first parentheses. That is a polynomial. It also can be classified as a trinomial, tri meaning 3. This problem is addition. See a big plus sign in the middle. And in the second parentheses, please notice that there are also 3 terms. So this is classified as a second polynomial. We have a polynomial added to another polynomial, and our job is to try to find the sum, the answer to that. Your first step is to group like terms. So you're going to go to the problem and you're going to look for all terms that have the same letter and same power. This one has an x to the first, here's another x to the first. So when your first step, if it's addition, you don't have to worry about changing any signs. You're just going to drop your 12x down. And then this is a plus negative. There's actually 2 signs here. We only want 1 sign in front of every single term. So when you have a plus and a minus together, it's automatically a minus sign. Remember, that's also a negative, so you can call it minus 4x or negative 4x. They really do mean the same thing. So you are to just drop it straight down. Please notice there is no equal sign in this problem. We are not transposing. We are not changing signs of anything right now. We are just regrouping. We're writing our x terms side by side. Okay, I'll color code it so we can follow. Next, we're going to look for the y term. There's a positive 5y, and in the second polynomial, there's a negative 11. So your job is to group them. Write them side by side, making sure you bring down the exact sign in front. Okay, the sign of the 11y is a negative. You're going to drop it down as a negative 11y. Again, all you're doing is recopying. Next, I see a z. A z term here is negative 3z, and the second polynomial is negative 7z. You are to drop down both terms side by side. Okay, and then after we group like terms, we didn't have to worry about step 2 because it wasn't subtraction. The next step says add or subtract the coefficients on like terms. So you're going to combine 12 minus 4, and that's just going to be an 8, so that's an 8x. Notice I did nothing to powers, I just copied the same letter down. Then a positive 5 minus 11, 5 minus 11, you can use your calculator if you need to. That's going to be a negative 6y. And then a negative 3 minus 7. If you're using your calculator, type it in as negative 3 minus 7. And that's going to give you a negative 10. And then again, drop your variable down. Do nothing with your powers. And that is the best answer to those two polynomials added together. Alright, let's try number 2. Example 2, what I want you to notice is, first off, there are 2 parentheses. This one has 2 terms, so it definitely is a polynomial. The second parentheses also has 2 terms. Then I need you to notice that there is a big minus sign in the middle. The first example was an addition problem. The second, obviously, is subtraction. So we are going to have to follow this rule. If there's a subtraction sign in the middle, you are to change all the signs of every term behind it. So this is what I mean by that. You are to think of this like, some people like to think of it like a negative 1. You are allowed to do that and just kind of distribute and multiply. But you're basically also thinking of it as like the opposite of negative 5 and the opposite of negative 2. So there's different ways to think about that type of problem. So the first thing I'm going to do is rewrite it. I'm going to drop everything down in the first parentheses. You don't need to change anything there. You might want to leave off the parentheses like I'm doing. Okay. And now because this is subtraction, I've got to change this sign from a negative 5x squared to a positive 5x squared. And now I've got a subtraction sign of a negative, so I'm like thinking negative, negative, or negative 1 times negative 2, and that's going to be a positive. Negative times negative is positive, and then 1 times 2 is 2. And then you're going to drop your x term down. So I've indicated here, let me erase this part, because again, making sure you understand, because if you miss this part, you'll miss all subtraction problems. If there is a minus sign in between polynomials, you have to change the sign of every term behind it. So notice that this one had a negative in front of the 5, and notice I dropped it down as positive. Same deal here, this was a negative, it becomes positive. It is saying the opposite of negative 5, the opposite of negative 2. Or, if you like the other way I said it, some people like to think of it as a negative 1. Negative 1 times negative 5 is positive 5. Negative 1 times negative 2 is positive 2. Doesn't matter to me which way you want to use, but you just got to make sure you know to change the signs. Okay, next you're going to look for the like terms. Like terms are terms that have the same variable and same power. 6x squared matches 5x squared. They have the same letter, same exponent. You are going to write them side by side. So it's going to say 6x to the second. Make sure you're following the sign now. You're going to copy it down. 5x squared. Again, all we're doing right now is rearranging the problem, so everything that we're going to put together is side by side. Then next, you're going to look at the x term. I've got a negative 4x and a positive 2x. I'm going to drop those two terms down. Okay, and now we have grouped terms together. We're now going to add or subtract the coefficients on like terms. These are like terms in green. You are adding 6 plus 5. 6 plus 5 is 11. You're going to drop your variable down and your power. There are 6 of these and 5 more of these, making a total of 11. Next, there is a negative 4x plus a 2x. Negative 4 plus 2 is a negative 2, and then you drop your variable down. Again, these are unlocked terms. That's the reason I cannot subtract this, so this has to be the best answer. That's pretty much it for adding, subtracting. We're going to look at this problem next, one more, and then we'll move on to the multiplication stuff. On number 3, I used another subtraction problem. You are to combine like terms, but first we've got to change the signs of everything behind the minus sign. So that should be your first step. Recopy. The 10 is going to become negative 10. This negative 6 is going to change to positive 6. And this positive 1 is going to change to a negative 1. So again, those signs in red have been the ones that have changed from the original problem. Alright, next we're going to group like terms. These two match. They have the same letter and power. So we're going to drop those down. Make sure you bring the same thing down. Okay, then we're going to bring down our a squared term. So let's see, this term and this term, those look the same. And then last, I see a b to the 5th here and here. We're going to copy it down as a positive 5b to the 5th. And a positive 6b to the 5th. Okay, now that the terms that look the same are side by side, you're ready to combine their coefficients. 2 minus 10 is negative 8. Next, negative 4 minus 1. And next, 5 plus 6. And for the third time, notice that I am not doing anything to these powers. I'm just dropping it down. 5b to the 5th plus another 6b to the 5th is a total of 11 of those terms. You can think of it that way. Alright, so again, that's your adding, subtracting rules. Group like terms. If there's a subtraction sign in the middle, you have to change all the signs behind it. You're going to just add or subtract depending on the signs. You're going to do that with your coefficients. And then you're going to do nothing to the powers. You're dropping the same letter and same power down. Again, that's adding, subtracting polynomials. Alright, next is multiplication. How do we multiply polynomials? Well, it depends on the problem. So I gave you two scenarios. First, when you're multiplying a monomial, one term, by polynomial, many terms, you can use what's called the distributive property. You do that in Algebra 1. And also, because distributive property means multiply, you're going to use the product rule, which also means multiply. So if you have a monomial, one term times several terms, you're going to distribute the monomial to all the terms on the inside. When you're doing that, you're actually doing the product rule, and this is just a quick review. That means to multiply the coefficients and add the powers if it's the same variable. Okay, so that works for monomials times polynomials. Second, when you're multiplying a binomial means there's two terms, and the other polynomial has two terms. You're going to use what's called the FOIL method, and you should have done this in Algebra 1. The FOIL method, just a quick review, making sure we all remember, is first, outer, inner, and last. And you can do it in that order. It's really basically the distributive property, to be honest, but it's just a nice, cute acronym to help you remember the order you're going to multiply. So first, outer, inner, last. First, F, O, I, and L. Okay, so we're going to take a look at example 1. And I want you to notice in example 1, I do have two terms in the first parentheses. Plus sign helps me see that. This is a polynomial, many terms, but more specifically, it's a binomial because it has two. The second parentheses also has two terms. So I have a binomial times a binomial. I do not see a plus or minus sign in between. So this problem is different from the last three examples we've done. Like this one was add, that's subtract. I'm pointing out the obvious right now, but I've had a lot of students in the past that don't pay attention to the sign, and then they miss a ton of problems. So again, this is multiplication. The rule says when you're multiplying a binomial times binomial, you are allowed to use the FOIL method. So let's start by making sure we remember this from the past. First would be these terms. These are your F terms. You are going to be in multiply mode. Well, since we're multiplying, we are thinking product rule. So you're going to multiply 3 times 2, bring it down. Then you're going to add powers on the same letter. So you're going to say x to the 4th times x to the 4th is x to the 4 plus 4, which is 8. Second, you're going to go with the O terms. O are the two terms that are farthest away from each other. The ones I'm putting in green. You're going to multiply 3x to the 4th times negative 3y. 3 times negative 3 is negative 9. X to the 4th, I don't see an x here, so I have to make sure that I bring it down. Sometimes that happens. You'll have different variables going on. And then this term has a y. I can't leave that out, so I have to copy it down. So 3x to the 4th times negative 3y is negative 9x to the 4th y. Third, we're going to go with the I terms. I is inside. Inside terms are the two that are closest to each other. So these terms. Positive 7 times positive 2 is positive 14. Y times, I don't see a y here, so we drop it down. I see x to the 4th here, so I drop it down. And the reason that I move that over is I like to put the letters in alphabetical order. That is a good habit to get into. So 14x to the 4th y. And then we're going to go with the last term. Last term is the term like here. And the last term in the second parentheses, those are my L terms. I'm going to put those in purple. So we're going to do positive times negative, negative. 7 times 3, 21. And y times y. And be careful here because remember, you're supposed to be adding powers and there's little ones here that you just don't see. And so it's going to be y to the second. There we go. So it's 21y to the second power. Okay, so we have finished the FOIL method, and now what we need to do is look to see is there anything on the board currently that are like terms. We're finished with the multiplication, but now it says subtract and add, and we can only subtract and add if the variables are the same and the powers are the same. When I look at the term in red, I see x to the 8th. I don't see another x to the 8th. So that just means that 6x to the 8th is part of the answer. Next, I see an x to the 4th y. Well, I have an x to the 4th y right beside of it. So these two are like terms, meaning you have to put them together. So now you're back to the add subtract rule from the last slide. You're doing -9 plus 14. -9 plus 14 is a +5. We're in add subtract mode right now, so now our brains have to switch back to that rule. Do nothing to powers, just recopy the variable combination. And then last I see this -21y squared, and there's nothing else that matches it to kind of put together, so I'm going to stop right there. And so the final answer for that problem is 6x to the 8th plus 5x to the 4th y minus 21y to the second. Alright, second example, I want you to notice in the first parentheses here, there is one term. I do not see a plus or a minus sign. I see a negative, but it's attached to the 6. So this is a monomial. In the second parentheses, I see two terms separated by a big minus sign. This is a polynomial. When you are multiplying a monomial by a polynomial, you're going to use the distributive property and the product rule. Okay, so let's try that. We are going to start with the monomial. We're going to distribute it to this term, and then after that we'll multiply those terms. Here we go. -6 times 4. Multiply the coefficients together, drop it down. We are in multiplication mode, so we are going to add powers on the same base. You're going to drop your letter A down, and you're going to add 2 plus the little 1 here, so that's a to the 3rd. Then you're going to drop your B down. You see 3 B's here, 5 B's here. There's a total of 8, B to the 8th. When you finish multiplying this monomial by this term, then you're done with that part of the problem. You now move on to the next piece, which would be the part I'm highlighting in red. You're now doing -6 times -3. What's your signs? -6 times -3. Negative times negative is positive. Be careful because I've had students in the past that just want to copy the same thing down. Pay attention to the sign in front. Negative times negative is positive. 6 times 3 is 18. Now we're on to the A's. We have a to the 2nd times a to the 3rd, which is a to the 2 plus 3, or 5. And then we have B, and we've got 3 plus 6, which is 9. Okay, so when I look at it next, I'm finished with the distributive property. All I have to do now is compare these two terms. Do they look the same? Do they have the same variable and power combination? Well, notice in the blue term I have a to the 3rd, b to the 8th. The red term, I do not have a to the 3rd, b to the 8th. And so because they are different, that means that this has to be the final answer. Okay, so that would be the product. Okay, so big 2 learning targets. You need to be able to add and subtract polynomials and multiply them as well.